So today we're going to look at how do we solve radical equations. So that's exactly what our objective is, solve square root equations. We'll actually look at some examples that are other indices besides square or 2. What would we do with the cube root equation, for example? All right, so first let's define what we mean by a radical equation. What is it that makes it a radical equation? Because if it is a radical equation, we have kind of a special way to solve it. So it's an equation that has a variable as a radicand or a variable with a rational exponent, okay? So if the index is 2 on the radical, then we call it a square root equation, but we can call all of these examples radical equations. So let's look and see, what am I talking about here? So here's an equation, 3 plus square root of x equals 10. Now, is this a radical equation? Well, yes, because the variable x that we're trying to solve for is inside the radical. How about this example? X minus 2 all raised to the 2/3 power equals 50. Okay, and we would say yes, this is a radical equation because it has a exponent that's a rational exponent, a fraction, and it's being applied to an expression that contains our variable x. Now, if you look at these two equations, the normal ways we have of getting x by itself, right, we kind of get stuck. So that's where we're headed here. How do we actually solve an equation like this? So let's look at this example. Is this example a radical equation? Well, the answer is no. It has an x in it. It has a radical in it, but the x is not inside the radical. It's not part of the radicand. So this is not a radical equation. Or how about this one? 5 raised to the 1/2 power plus x equals 1. Well, again, it has a variable x and it has a rational exponent, but the 1/2 is not being applied to our variable x. So this is not a radical equation. All right, so here are some examples. Take a minute, just yes or no. Which of these do you believe are radical equations? Okay, hopefully you paused that and then wrote your answers down in your notebook. Let's go through this. Let's look at A, right? The answer is yes. The x is inside the radical as part of the expression that makes up our radicand. How about B? The answer is yes there also, right? 2x minus 1 is all being raised to a 3/2 power, a rational exponent. How about C? Well, if you said no, that's correct, right? We have 5x, but it's not part of the radical. It's not in the radicand. And then D, the answer would be yes, right? 2x is all being raised to the 1/5 power. All right, let's try 4 more, same thing. Okay, here we go. A is yes, right? X is inside the radicand. B is no, the x is not part of the radicand. C is yes, and D is no, right? We're raising 4 to the 1/2, but there's no variable that's being raised by that exponent of 1/2. All right, so we know how to recognize what a radical equation looks like. How are we going to solve it? Okay, so I'm just going to walk through some examples that will show you the strategy for solving a radical equation. And there's a few basic steps here that will take the same approach each time. So the first step is to isolate the radical on one side of the equation. In other words, we just want the radical and the radicand on one side, everything else on the other. Now, this example that we're doing first here actually already has the radical isolated, right? What I highlighted in yellow here is the radical, right? With x plus 25 as the radicand, and that's already by itself on one side of the equation. So we don't need to do anything in this problem. We'll get to some examples where we will have to do some work to isolate the radical. Okay, so now the next step is, how do we get rid of the square root? Okay, because this is the problem. We can't just subtract 25 and then solve for x because it's inside this radical. But what we can do is raise both sides of the equation to a power that's the same as our index. And that will allow us to get rid of the radical. So what would that actually look like? Here's what it would look like, right? Our index is 2. We're taking the square root. So if we raise that entire radical to the second power and do the same thing on the right side of the equation, so we have 4 squared, what will happen? Well, remember, taking the square root and raising something to the second power, those are what we call inverse operations. So they, in effect, cancel each other out. And when we do that, we now will just have what was inside, just the radicand. So that just becomes x plus 25. On the right-hand side, we need to go ahead and square the 4, so that gives us 16. But now we have a very simple equation we can solve, right? To get x by itself, we're just going to subtract 25, and we get x equals -9. And then the last step is to check your solution. So let's take the -9 and put it back in for x, and then do the arithmetic, right? So -9 plus 25, that would give me a positive 16. And yes, the square root of 16 is 4. Okay, so there's kind of a simple example, but the key strategy here is isolate the radical first if we need to. And then to get rid of the radical, we need to raise both sides by, in this case, a power of 2. All right, here's the next one. So first step, isolate the radical of the left side. So we want to get square root of 3x minus 3 all by itself, which means we need to move the 2 and the 5 to the other side. Now, here's the common point of confusion. Which one do I do first? When you're trying to isolate or solve an equation and you have a choice between either subtracting 2 or dividing by 5, you want to do the addition or subtraction first. It's kind of opposite of normal order of operations. So the first thing we want to do here is subtract 2 from both sides, okay? And this is what we get. We get now 15 on the right side. Now we can divide by 5. And if we do that, right, we are left with square root of 3x minus 3, and 15 divided by 5 gives us 3. So those first 2 steps were just so we could isolate the radical by itself. Now we're ready to raise both sides by the same power. So since our index is 2, we want to square both sides. And when we do that, we get rid of the radical. We now have 3x minus 3 on one side and 9 on the other. So simple equation to solve, right? We're going to add 3 to both sides. That gives us 12, divide by 3, and we get our answer of 4. Now, let's check our solution. Okay, so if we put in 4 for x from the original equation, yeah, a little bit of arithmetic to do here, right? We'd have what? 3 times 4 is 12, minus 3 is 9, times 5 is 40. Well, actually, square root of 9 is 3, and then 3 times 5 is 15. Okay, and so let's see. Oh, I subtracted 2 here as part of this step 2. So now we get to 5 times 3, and that indeed gives us 15. Okay. All right, let's try a couple more examples. See if you can do this one on your notes. Pause it, solve it, and then see if you got the correct answer. Okay. We don't need to isolate the radical. It's already done for us in this example. So we're just going to square both sides. So we get x minus 3 equals 100. 10 squared is 100. And then simple equation to solve, we get our final answer of 103. Let's check our solution. 103 minus 3 is 100. And yes, the square root of 100 is indeed 10. All right, let's try another one. A little more complex here. Go ahead and pause it and solve it. Okay, so we do need to isolate the radical here, which means we want to subtract 2 from both sides. Now we can square both sides to get rid of the radical. So we wind up with x plus 1 equals 4. And x equals 3. All right, let's check it, put it in there. 3 for x, we have 3 plus 1 is 4. Square root of 4 is 2, right? So 2 plus 2 gives us 4, and that works. All right, here's another one. See if you can solve this one. A little different than what we've done so far. Notice the index. Okay, same steps. Let's isolate the radical, which means we need to move the -4 to the other side by adding 4. And we do that, a -1 and a +4 gives us a +3. Now, to take the cube root of x, we want to get rid of that radical, right? So here's an example where we want to raise both sides to the same power of the index. And this is the first one where the index has not been 2, right? It's not been square root. This is cube root. So we want to raise both sides to the third power here. We know how to do that. So we're just going to be left with x on the left, and 3 to the third power is 27. And we basically have our answer. There's no more steps we need to do to really solve for x here. All right, let's check our solution. Cube root of 27 we know is 3. 3 minus 4 does give us a -1. All right, one more. Give it a try. All right, so we do need to isolate the radical. So we're going to divide by 2 since it's 2 times our radical. So we get cube root of x minus 3 equals 2. Now we're going to raise both sides to the third power. So that gets rid of our cube root on the left, and 2 to the third gives us 8. Now, simple equation, we add 3 to both sides, and we get x equals 11. Let's check our work. 11 minus 3 is 8. Cube root of 8 is 2. So 2 times 2 is indeed 4. All right, that's it. So you now know how to solve square root or even cube root equations, right? The last couple examples we saw there are cube roots. So there's an assignment in Google Classroom, about 12 problems for you to practice on this. Go ahead and work on those.